Hello everyone, welcome to Sizesoft Academy. Here we are empowering the education through digital content, and this is me Mallikarjuna, and today we are going to talk about the compile time polymorphism versus runtime polymorphism. So what are the basic differences between them? And we are also going to see a live demo on that. So without further delay, let's get started. So let's talk about the differences between compile time polymorphism and runtime polymorphism. So in case of compile time polymorphism, we are achieving it through compile time. So the binding is actually occurring at the compilation of the code. So but when we come to the runtime polymorphism section, so during the compilation time, the compiler doesn't know which method it's actually invoking. So it will come to know only at runtime. So that is why it is called as runtime polymorphism. So compile time polymorphism is achieved through static binding, whereas runtime polymorphism is achieved through dynamic binding. So in case of compile time polymorphism, there is no concept called inheritance. So this compile time polymorphism is achieved through method overloading. Okay, but in case of runtime polymorphism is achieved through method overriding. So the method overriding concept comes into picture only in case of inheritance. So those who are not aware of what is inheritance, so this we have explained in our previous episode as well, but let me give you a glance of what is inheritance. So for example, a child is inheriting their parents' behaviors and characteristics, and also the child can have its own characteristics. So this is what basically called inheritance. So in classes also the same will get implemented. So now let's see a live demo on method overloading as well as method overriding. So let's first talk about the environmental setup before we go into the live demo. So here we have our Visual Studio Code installed and set up with the pre-configured Java extension. So it is pretty simple to download and install the Visual Studio Code from the Google. To search for it, we will get it in the first link itself. And the second thing we need to have is the Java runtime. Java JDK needs to be installed. So in our system, if you see, if I just run Java version, we have 1.8 version installed. So you can have 1.8 or above versions that needs to be installed. And after that, if you go to extensions in the Visual Studio Code, if you search for Java, you will get the Microsoft's published Java extension pack. If you see, we have an extension pack for Java. So in our system, since it's already installed and configured, it is showing as uninstalled for us. So for you, so you have to install that extension pack so that you will get the run button directly on the class itself. So I think I have covered most of the environmental setup. So now let's deep dive into the compile time polymorphism example. So as I was explaining earlier, the compile time polymorphism is achieved through method overloading. So method overloading is a concept where we can actually invoke different actions using the same method name. So to achieve this method overloading, we can use in two ways. So the first way is actually by differing the type of the parameters that is passed, or by varying the number of the parameters that is passed. So these are the two types that we can achieve the method overloading concept. So here in our class, in our sample class, if you see, we have a display method, which is actually overloaded into 4 different implementation. So each implementation is actually printing a customized message. Let's say if you say the first display method is not taking any parameters, which is going to print a customized message for that specific method. And if you take the second method, we have an integer parameter which is coming in. And if you see the third method, which is actually we are differing by the number of parameters that are passed to the method. And fourth implementation is actually by varying the type of the parameter. So I hope this implementation is clear for you. Let's go ahead with the demo, like how this class is going to work with it. So let's go to our sample class. Let's create an instance of the sample class. So let's say this is our object, new sample. Okay. So here what we will do is we will try to invoke all of the display methods and their implementation. So first thing, we are triggering the plain without any parameterized that method implementation. And the second one we will call with an integer. and the third one we will try to call with two different integers, and fourth one we will try to call with a string, and we can able to see different results for all these method calls. So let me run and show you the data here. So here it's compiling now, and if you see example, so first method actually gives us method without any parameters, and the second invocation actually gives us an integer value implementation, and third method gives us the two integer value implementation, and fourth the method function call is actually gives us the implementation for a string value. So I hope this compile time polymorphism example is clear for you now. So how it is achieved through method overloading. So now let's talk about the runtime polymorphism. So when we come to runtime polymorphism, as we are explaining earlier, so the runtime polymorphism is achieved through inheritance. So inheritance is actually inheriting the characteristics and behaviors from the parents. So here let us define a parent class and child class to understand the concept in detail actually. So let's like here we have an example class called parent, which is having a method called display. So which is actually just printing the customized message for parent class, displaying inside parent class. And let us define a child class which extends the parent class. What we meant by extend is we are trying to inherit the properties of the parent class. So that is what it meant by. And now we will try to declare the same method in child class also. So by declaring in this way, we are actually implementing the concept of method overriding. So let's see how it works in real time. So here let us create an instance of the child class actually. So this is an object, new child class. Yeah. So now we will try to call the display method here. So now we will see how the compiler doesn't even care about the method implementation, because here we have a parent object declared during the compilation time. So when we compile this code, the compiler doesn't check what object is stored in this obj string. So only during runtime we will come to know which method is going to get invoked. So that will be the behavior for this runtime polymorphism example. So let's see now. So in our case, since we are creating a child instance and we are triggering the display method from the child instance, the child class customized message should be printed. So let's see that in demo. Here, as you can able to see, we are actually displaying inside the child class. So I hope this comparison is clear for you between the compile time polymorphism and runtime polymorphism. Please do let us know if you have any questions or clarifications in the comment section. Thank you for watching this video, guys. See you in the next one.